Hello and welcome to this lesson on circle theorems. Firstly, you need to complete this do now task. You need to work out the labelled angles for each question. So show your working and pause the video while you do these. Answers then. Question 1. We should have 62 degrees due to angles around a point. Question 2. We should have 57 degrees due to angles in a triangle. Question 3 is 120 degrees due to angles in a quadrilateral. And question 4, you can see all of those angles. These are angles on parallel lines, and there'll be a variety of rules that you will have used. So this section is on circle theorems. We're just going to introduce the first few today, but overall the chapter is going to look at all the circle theorems, including cyclic quadrilaterals and how to use tangents, chords, and the alternate segment theorem. So this is a list of what we should already know. The first 3 points were covered in the do now task. We're also going to have a quick recap of the different parts of a circle. So the gold objective, which is something we haven't yet mentioned, we'll be looking at proof questions and how to set out our answers for that. Okay, parts of a circle. See what you can remember. Pause the video while you have a think about them. Okay, let's go through them. We will start with the circumference, which is the perimeter. Next, we've got the line across the middle, the diameter. From the middle to the edge, the radius. Here, we have a sector. Here we have an arc. This is the minor arc because this part of it would be the major arc. Same with the sector, the other part would be the major sector. This line across here is a chord. Then we have a segment. This one is the minor segment. If it was the other side of the line or other side of the chord, it would be the major segment. And then here we have a tangent. It's a straight line that touches the circumference of the circle at one point. So you need to be aware of these key terms. Okay, so looking at circle theorems, they apply both to lengths and angles. So we're just going to have a quick look at a couple of things that are not circles, but they're really useful to be able to spot. So angles in a quadrilateral adding up to 360 degrees. It's really useful that you remember that and you can spot where quadrilaterals are drawn. So this particular example, the missing angle is 130 degrees. It's also really important to be able to spot isosceles triangles. So they won't always have these two lines drawn on to show that they are the same length, but that can often be shown by the fact that both of these lines could be a radius of the circle and therefore they would be the same length. And that means that these two angles at the base would be the same. So that's something again to keep an eye on. Okay, our first circle theorem, or our first two circle theorems, both involve right angles. If you sketch these into your books, so you've got a clear example of what they are, and the wording in the black box, that is what we say to describe this circle theorem, because sometimes we're asked the reason. So the first one, we've got a radius and we've got a tangent, and the angle between them is 90 degrees. The second one, we've got the angle in a semicircle. That is because we've got the diameter. So we've got the diameter and a triangle. The angle in a semicircle is 90 degrees. The next two circle theorems that we are going to look at today. Firstly, angles in the same segment are equal. So we've got a segment here. You can see that they start at the same edge of the chord. Now the chord won't always be drawn in, but we can see here, this angle here is the same as the other angle there. And it could be drawn over to any point on the circumference. So the angles in the same segment are equal. And the second one on this slide is the angle at the centre is double the angle at the circumference. Note that they have to have the same starting point as well. Again, make sure you've got these two in your books. So these are the 4 circle theorems that we're going to be looking at today. Let's look at some examples. So we need to work out the size of angles marked A and B in each diagram, and O is the centre of the circle. So looking at question A, hopefully we can see that A is in the same segment as the 35. So therefore A equals 35. We also have angle B has the same starting points as 35. So the angle at the centre is double the angle at the circumference. So angle B in this case is 70 degrees. Now the second example. We're going to work out question A first, or angle A first. Notice we have a triangle, it's isosceles. So it's isosceles because they're both a radius. So these two angles are the same, and therefore we can use angles in a triangle, and we end up with A equals 130 degrees. Then angle B is half the angle at the centre, 65 degrees. Another example for you. We're given that the centre O, we're given PQR is a straight line, and it says show that A equals 144 degrees. Now we can't use 144 in our calculation. That is an answer we must get to. First thing we can do is to show that angles on a straight line. That means angle PQT is 108 degrees. Now angles at the centre are double the angle at the edge. So in this case it's the reflex angle. So to then get angle A, you're going to subtract from 360 degrees. And we've got the answer 144 degrees, which is what we were looking for. Okay, you're going to have a go at these. It'll be very useful if you have these printed out. If not, sketch them. It's much easier to work them out when you can label things on the diagram. So pause the video while you work through them. Okay, let's check the answers then. Question A, X is 56 degrees, double the angle at the edge. Question B, 62 degrees, double the angle at the edge. C, 105 degrees. The angle at the edge, or the circumference, is half of the angle at the centre. So they can work both ways. Question D, we're going to be using the fact that this is an angle made by a semicircle. So the angle here is 90 degrees, and then you've got angles in a triangle. Question E, you've got two sides the same. You've also got a diameter. So we know that this is going to be 90 degrees. And since it's an isosceles triangle, we have 45 degrees. Question F, those lines tell us that we have got an equilateral triangle. So all of these angles are going to be 60 degrees. So since we've also got a diameter, this is a right angle, so that is 90. 90 take away 60 gives us 30 here. This is an isosceles triangle, so this X is also 30. Question G, X is going to be the same as this angle here, because they both got a radius, so that is an isosceles triangle. Angle at the centre, double the angle at the edge, so we've got 60. These two are the same, which means they're both 60 degrees. Question H, we are going to have angles on a straight line, so this is going to be 110. We've got two radii, so these two angles are going to be the same due to an isosceles triangle, and then angles on a straight line again, so 145 degrees. Okay, well done if you got all of those, especially giving the reason as well. Okay, have a go at these ones. Again, pause the video while you do these. Okay, let's check these answers. So question A is 55 degrees. That comes from having angles in the same segment. This angle here is 35. Then we've got a diameter, so a right angle. So 90 take away the 35 gives us that 55. Question B, X is the same as this angle here, and due to angles in a triangle, it's 52 degrees. Question C, we've got parallel lines, so that's key here. So angles in the same segment gives us this as 50 degrees, and then it's alternate angles. So X is 50 degrees. Question D, angles in the same segment gives us 61 degrees for this angle here, and then angles in a triangle gives us X is 24 degrees. Question E, due to the angles in the same segment, this angle here, cutting the 105, is 66 degrees. So 105 take away 66 gives us this angle, which is the same as X, which is 39 degrees. Question F, we've got a diameter, so that full angle there is 90 degrees. And then due to angles in the same segment, this little angle here is 10, so that gives us 80 for X. Okay, question G. The angle at the centre is double the angle at the circumference, so X is 34 degrees. And then finally, question H. We've got vertically opposite angles are equal, so that's 60. We've got 90 here due to the diameter, and then angles in that little triangle, X becomes 30 degrees. Okay, question 3. Again, it'll be useful to have this printed out or drawn out so you can write on it. So we want to label and work out the size of angle ADB. Angle ADB, that's this angle here. It's going to be 41 degrees due to angles in the same segment. DBA, so DBA is going to be this one here. Well, since we've got a diameter, this is a right angle, so we get 49 degrees. CAD here is going to be 41 degrees, and that's due to the fact that we have an isosceles triangle here. Okay, question 4. Again, pause the video while you do this one. Okay, question A, EDF, this angle here. Now we can see that we've got a right angle, so subtract 18 from it to get 72 degrees. Angle DEG, well, that is in the same segment as DFG, so is 37 degrees. And then EGF, this angle here, is going to be 72 degrees because it's in the same segment as EDF. So it's the same. Okay, let's have a look at another example. So getting a little bit more challenging now. So the first thing is to work out the size of angles A and B. So let's do that. So firstly, we can see that angle A is the angle at the circumference, and 64 was the angle at the centre, so we're going to half that to get angle A. And then we've got a diameter, so we know that this angle PTQ is 90 degrees. And then using allied angles, we know that A plus 90 and adding B is going to be equal to 180, which gives us B is 58 degrees. Okay, and now the more challenging part. What size would you need to make angle ROQ, so that's the one currently labelled 64, for PTRO to become a parallelogram? If we let RTQ, that's currently labelled A, if we call it X, then ROQ would have to be 2X, due to the fact that it's at the centre and A is at the circumference. TPQ, this one here, is going to have to be 2X due to corresponding angles, because these are now parallel due to parallel lines. And opposite angles in a parallelogram are equal, as are opposite angles. So if we add everything together, that's these three parts here, to get 180 we're going to get 3x plus 90 equals 180. Therefore, when we solve that, we get x equals 30. So for us to have a parallelogram, the angle that's currently labelled 64 would need to be 30 degrees. Okay, question 5. Pause the video while you work this one out. Now again, this is a show that question, which means that you cannot use 55 in your working. We can see that AY and AZ are both the radius, and therefore we've got an isosceles triangle. So we're going to have 35 degrees for each of these angles. We've got a diameter, so x, z, y is going to be 90, and then 90 take away the 35 is 55. Okay, question 6, again pause the video while you work through these. Okay, question A. X and Y are in the same segment, so they are equal to each other. So we only really need to work out one of them to get both. So here, we've got a straight line, so this angle is going to be 30 degrees. This angle here is at the circumference, and it's going to be half the angle at the centre, the reflex angle. So we work out the reflex angle to be 220, this angle to be 110, and therefore angles in a triangle, we get 40 degrees for each of those. Question B. For angle X, we've got angles in a triangle, so we get 131. We can see that this is going to be 20. We've got a straight line, so we can get this angle here, and therefore angles in a triangle, Y is 111 degrees. Question C, we can work out the missing angle in the triangle, which is going to be half of that reflex angle, and then subtract it from 360 to get 134. Isosceles triangle, Y is 23. Okay, again, 3 more questions for you. Pause the video while you work them out. Okay, question D. You are mostly going to be using angles and triangles here and angles on straight lines. We'll first notice that this one, we are going to use some circle theorems. 59 degrees, this is going to be 59 degrees, this is going to be 51 degrees. Then we're going to be using angles on straight lines and angles in triangles. So we get that angle X is 32 degrees and angle Y is 19 degrees. Question E. So we are going to have, we've got an isosceles triangle, so we can work out the angle at the centre, find the reflex angle, because the angle at the edge, Y, is going to be half that angle, to get the 121. And angle X is going to be half of the angle that was the obtuse angle, so 59 degrees. Okay, question F. So we can see here that we're going to have a straight line, so 155 degrees. Due to the parallel lines, that's going to be the same as X. Isosceles triangle, so we can get this little angle here, which is going to be 12.5 degrees, which is the same as Y. Right, another question, pause the video while you work this one out. Okay, so this little angle is going to be 15 degrees, so we can get the full triangle. This angle here is going to be 127, so we can get 53 here, and we can get the fact that these two angles are going to be the exterior angle of the triangle, which is 68 degrees. Question 8, a bit more complicated. It's a proof question, so we're going to be doing this in terms of X. So what we've got is that if we know this is X, this is going to be 180 minus X. The angle at the centre is double that, so 360 take away 2X. Or the reflex angle then, we're going to have to subtract from 360, and that gives us 2X. Question 9. Again, pause the video while you work through this one. Okay, so question A. State the value of angle BAO. You've got an isosceles triangle, so it's X. Angle AOD, well, that's the angle at the centre, so it's going to be double the angle at the circumference, so 2X. And it wants us to prove that the angle subtended by the diameter of a circle at the circumference is a right angle. And if we use this idea, what we've got is 180 degrees and 90 degrees. The angle at the centre is 180, which is double the angle at the circumference, 90 degrees. Question 10. This one's much easier if you draw it out and label the values. So you've got 53 degrees and you've got 17 degrees. You've got an isosceles triangle. So you can get 74. The reflex angle is going to be 286. The angle at the edge is half the angle at the centre, 37. And then you've got an arrowhead. So quadrilateral. Subtract 340 from 360 and you get 20 degrees. Question 11 is more of a proof question, so pause the video to read through this one to see if you can follow that through. Okay, next slide shows us all of 7 circle theorems. We've covered some of them. Can you spot those? And as it says, it might be an idea to print this off so then you've got all of those circle theorems in one place. And that is it for today. Well done.